This is Mr. Gillum, and today we're going to be moving on to Lesson 14, Day 1, your instruction book on page 128, and we're going to be learning about the coordinate plane. This is a coordinate plane. The actual two axes is what we call them. Each axis that we have is a y-axis and an x-axis. Okay, and it's itsy bitsy on my screen, so I'm going to make it a little bigger. X is side to side, y is up and down. It has some information over here about x and y. That's how we describe where a point is on the coordinate plane, x comma y. The x value moves from the origin left and right. The y value moves up and down. Positive at the top, negative at the bottom, positive to the right, negative to the left. So when we're talking about the coordinate plane, we always start counting from the center, okay? This is called the origin, all right? That's the ordered pair would be 0, 0. We haven't moved left or right, and we haven't moved up and down at all. Some of the most confusing points are when we have a 0 included in our coordinates, okay? And so it's very important to keep in mind that the x value comes first and the y value comes second, okay? So in this case, we would move left and right 0, up and down 2. So it would be that point right there. And in this case, we'd move left and right 2, up and down 0. It would be on the x-axis. So that's one of the more confusing parts of the coordinate plane is when the points are actually on an axis. What we're going to learn here in a second is about quadrants, and we'll talk about these instances when you have points on the axes. They're not actually in one of the quadrants, okay? So let's move on and take a little look at the examples. It says, place your finger on the origin. Okay, so I'm going to actually use my little green deal here. So there's the origin. You can see my little, that's my finger. We're going to pretend that's my finger. That's the origin. And we're going to move 5 units to the right and 4 units up. So to the right. So 1, 2, 3, 4, 5. And then 4 units up. 1, 2, 3, 4. It says, the ordered pair for point A is, this is the left and right number, so I know that I went right 5 units, and that is the positive direction. This is the negative direction, positive direction, negative direction. So positive 5, comma 4. That's where point A would be. It says place your finger on the origin. Okay, let's use the red one this time. So here's my finger on the origin. It says move left and up to point B. Describe how far left and how far up B is from point 0, 0. So, okay, I need to move left, 1, 2, 3, 4, negative 4, 4 in the negative direction, and then 1, 2, 3, up 3, so 3 in the positive direction. We always go left and right first, up and down second, x first, y second. And so if I want to describe that, I move negative 4 spaces and then up 4 spaces, or 4 units to the left and 3 units up. The ordered pair for B is negative 4, 3. We chose 3 and not negative 3 because we're going the positive direction. Notice how I did not write a plus sign in front of the 3. I just wrote 3, and that indicates positivity. It says start at point 0, 0. And describe how to get to point C. What is the ordered pair for point C? So again, we're going to start the origin right in the middle. And this is where we always start at 0, 0. That means we haven't moved left or right or up and down at all. And I'm looking for point C, which is this guy right here. Now, some of you may be tempted to go down first and then left, but remember, we always want to use our x-axis first. So we want to stay on the x-axis as long as we can, and then we move up and down from there. So I'm going to move left 1, 2, 3 places. That was negative 3, and I'm choosing a negative this time because I'm moving to the left. Remember, this is the positive side, and this is the negative side. So I move 3 to the left, and then 1, 2, 2 down. Again, this is the negative side, and this is the positive side because I'm going down from 0. We call that negative 2. So that's my ordered pair, and I can describe that by saying we moved left 3 units and down 2 units. And when I describe where the location is, I always want to talk about left and right first, up and down second. So I move 3 units to the left and 2 units down. The ordered pair is negative 3, negative 2. It says, what is the ordered pair for point D? It doesn't say to describe its location, but we can do that as well. Here's point D, and we're going to start at the origin. And I'm going to talk about my right and left side movement first, the X first. It's always X and then Y. Always that order, alphabetical order. We call it the horizontal axis and then the vertical axis. So if I'm going from 0, 0, I want to talk about this axis first. So I'm going to go 1, 2 to the right, or in the positive direction, so 2. And then we need to figure out how far up or down we're going. In this case, we're going down towards the negative, so 1, 2, 3, 4. Down 4 units. So 2, negative 4 would be my order pair. Explain how to locate points on the coordinate plane. Okay, so to locate points on the coordinate plane, what we do is this. We start in the middle of the what we call the coordinate plane, and then we move left or right, and then we move up or down. Okay, it's always left and right first, up and down second. Always in that order, always X and then Y. And then, of course, we know that negative side is to the left, the positive side is to the right. This is just a number line, and if I rotated this number line to the left, counterclockwise, it would make another number line that is identical to it. We call that the y-axis. The top is positive, the bottom is negative. Top, up, positive, down, negative. I remember that because I think of a thermometer. It says on the previous page you wrote ordered pairs to describe points on a coordinate plane. The x-axis and the y-axis intersect at the origin and divide the coordinate plane into 4 quadrants. So we literally have a number line, just like all the number lines we've ever done with 0 in the middle. And we have another number line that is this number line rotated sideways. So that just makes it go upside down or sideways. And again, 0 is in the middle of that number line. So in the middle here, we call this the origin, or the point 0, 0. All right. To describe the location of a coordinate, we use quadrants. Now, when I say the word quadrants, you might hear the word quad, and hopefully you know that quad means 4. And so there are 4 areas of our coordinate plane. The first quadrant is anything that lands, any coordinate that is in quadrant 1 is in the top right-hand corner. You'll see what we call Roman numerals for this. So in the top right-hand corner is Roman numeral 1. We can just say 1, quadrant 1. And there's something special about all the coordinates in quadrant 1. They're all positive on the x-axis because you have to move to the right, and also positive on the y-axis because you have to move up into the first quadrant. The second quadrant is in the top left-hand corner. Okay, a lot of times students want to confuse quadrants 1 and 2, and they want to order them their own way, but this is actually quadrant 2, and that's actually Roman numerals for quadrant 2. Sometimes they put the little deal like that. If you ever watched the Ninja Turtle movies, they have the Roman numerals, or if you've seen the Super Bowl, they use Roman numerals as well. That's quadrant 2, and there's something special about all the coordinates in quadrant 2 as well. To get to quadrant 2, we always need to move backwards on the x-axis, a negative value, and upwards on the y-axis, a positive value. So any coordinate in quadrant 2 will be a negative x value and a positive y value. That's consistent for any coordinate with a negative, positive is always in quadrant 2. Then we go to quadrant 3. It's this one. 1, 2, 3. Boom, right there. And there's special characteristics about coordinates in quadrant 3 as well. Again, we must move left on the x-axis in the negative direction. But then we also need to move down to go to the bottom quadrant in the y direction. So any coordinate in quadrant 3 has a negative x value and a negative y value. We're going left and down. And then finally, we have quadrant 4. And so you're going to learn a little about Roman numerals here in a second. IV is how quadrant 4 works. And to get to a location in quadrant 4, we need to move right on the x-axis in the positive direction, and then down on the y value. Down will be the negative direction. So we have to move to the right and down. So always the x will be positive and the y will be negative. You'll end in the fourth quadrant. So just a real quick history about Roman numerals. Here's how they work. Roman numerals, that represents 1. This number represents 5. It looks like a V. And then this number represents 10. I know L is 50, and there's other ones there's including, but the way it works is this. So 1, 2, 3. The way to represent 4 is by putting a 1 in front of the 5, representing 1 taken away from 5. So this would be 4. And then 5 would be like so. And then when we put 1s behind the 5, it means we're adding the 1s onto the 5. So we need a 5 plus a 1, that would be 6. 5 plus 2 1s would be 7. 5 plus 3 1s would be 8. And then when we get to 4 1s after, we don't do that anymore because we're closer to the next value. We actually write the symbols in front of the next symbol. So when I get to 8, instead of writing VIII, I would write IX. That represents 1 in front of 10, which would be 9. And then, of course, 10. And then, of course, we do the same exact pattern on and on and on until we get to 20. It would just be 2 X's. Okay? So that's basically how Roman numerals work. 1, 2, 3. When you get to 4, we don't add just another 1 on there. We talk about it, since it's closer to 5, we talk about 1 in front of 5. So that would be 4, and then 5, 6, 1 after 5, 7, 2 after 5, 8, 3 after 5, and then 9 would be 1 in front of 10. So 1 in front of 10 would be 9, and then 10, and then 11 would be XI, and we would continue on with the same pattern. Okay, L would be 50. There's a special Roman numeral for 50, and so on. But that's how Roman numerals work. If you were curious about that, as a little side tidbit there. So yeah, we need to know about which quadrant is which coordinate is in. We have 1, 2, 3, and 4. They go counterclockwise, starting in the top right-hand corner. It says describe the location of points A, B, and C, A, B, C, and D on the graph below. So if we talk about the location of point A, we can identify that as 5 to the right for our X value, and then 4 vertically and as a Y value. So positive 5, positive 4. Notice there are no plus signs on there. Just got 5 and 4. And we're also in quadrant 1. Here's quadrant 2, here's quadrant 3, here's quadrant 4. So those two things describe the location of point A better than talking about left and right, up and down. Point B, here, we are going 1, 2, 3, 4 in the negative direction, negative 4, and 3 in the positive direction, positive 3. We're in the second quadrant. C is in negative 3, negative 2, 1, 2, 3 back, 2 down, negative, negative. You can see that that is in quadrant 3. And then finally, 2, negative 4. 2 to the right, 4 down. That's where D is, and that's in quadrant 4. You can see the positive, negative values there for each one of those. Match what we were talking about on the last page. So we have points like E and F where they're not actually in a quadrant because they're actually on an axis line. So we would say that they're not in any quadrant. It says that point E is at negative 2, 0. Move backwards 2, up and down 0. It's actually on an axis. Every point on the x-axis of y-coordinate is 0. Point F is at 0, negative 3. We didn't move left and right at all, but we went down 3. So that is also on an axis. It's not in a quadrant either. Its x-coordinate is 0. So anything on the y-axis means we didn't move left and right at all, making the x-coordinate 0. Anything on the x-axis, we didn't move up and down at all, making the y-coordinate 0. It says describe the location of a point that has a negative x-coordinate and a negative y-coordinate. Well, if we went to the left, I guess I can just draw a new picture. If we had our graph here, here's the x values, here's the y values. They're both number lines. Positive here, negative here, positive here, negative here. And I went negative x-coordinate, so I went to the left. And a negative y-coordinate, I went down. No matter what, I will always be in quadrant number 3, no matter where it is. If I just go a little left and a little down, long ways left and a little down, it doesn't matter. Anytime I move negative in the x direction, negative in the y direction, I will still be in quadrant 3. to the left of the origin and below the x-axis. So that's it for today. We learned about our quadrants.